This example also asks us to find the domain and range of a graph. This graph is different from the prior example because it's a smooth curve as opposed to just a finite number of ordered pairs. Notice that this graph has what we call closed endpoints. In other words, here and here, those dots are included, or they're closed, meaning that those ordered pairs are included and a part of my graph. The graph would be what I would call smooth. In other words, it's a nice parabola-shaped graph, and there are no, I'm going to say, ordered pairs that are missing in between the two endpoints. When you have something that's a smooth graph, your domain and your range will be an infinite amount of values, meaning an uncountable amount of values. The domain are my x values. If I have a graph such as this, I want to see how large are my x values going to get and how small are my x values going to get. We can see, looking left to right on this graph, the furthest to the right these values are going to get is the endpoint here in this situation, and if I go up, then that value, it looks like positive 3. So the most that my graph is going to be is positive 3. The least that my graph is going to be looks like it's determined by that point. If I go straight up from there, that's going to be negative 3. We're going to write our domain in what we call interval notation. Interval notation, you have to write the smallest value on the left, the largest value on the right, and then you indicate if the large and small values are included or not included. This situation, negative 3 is our smallest value, positive 3 is our largest value, and every single number in between those are included because my graph was smooth. Now, negative 3 and 3 are both included because I had the endpoints solid. To include a number in interval notation, you're going to use a bracket. It's kind of like a box to include something. Now, for the range, let me erase what I've done for the domain. For the range, we will look at y values. We want to determine what is the lowest y value and what is the highest y value. Be careful because the two endpoints of your graph don't always necessarily determine your domain and range. It did for the domain in this case because the two endpoints were the furthest to the left and the furthest to the right that the graph extended. For the range, we want to see how low does the graph go and how high does the graph go. Well, the lowest it goes is here. So it would be negative 5. The highest it goes would be here. That value would be positive 4. Now if we look at our graph, we can see that our graph actually goes through that value, and so that value of 4 would understood to be included. The same thing here, we have those actual points as included points, and so the negative 5 would be included as well. So we would want brackets around these two values to include them.